Alright, so I'm talking about arguments for population reduction, specifically focused on the case of climate change. So my question is, do considerations of climate change give us a reason to reduce population size relative to business as usual? And if so, how exactly do the details of those arguments go? Which are the good arguments of this form? Okay, so as an outline of my talk, I want to start with some generalities, that is, thoughts on the connection between this project of arguing for population reduction and population axiology, just in general terms, i.e. not yet specifically about climate change. And then I want to turn to the case of climate change as a case study. So one hears a lot of things said about population reduction and climate change. They're usually left at a relatively sketchy level. I'm going to pick one example of something I've seen in print along these lines. And then for this particular example, I'm going to argue that it's a bit confusing, to say the least, because it's based on a misunderstanding of the relevant climate science, and then I'll try to clean things up and say how maybe the argument should go. My conclusions will be a bit inconclusive. They'll be along the lines of, there may well be a good argument for population reduction stemming from considerations of climate change. We haven't yet seen exactly how it goes. Here's where I think we should be looking. Okay, so in general terms then, by arguing for population reduction, I mean arguing for the claim that the optimal instantaneous population at a time, is lower in the short to medium term, so over the next 50 to 100 years or so, is lower than the instantaneance population you'd expect to get under a business as usual scenario, i.e. the kind of thing that will happen if we don't make some concerted efforts to influence it. So there are lots of non-profit organisations entirely dedicated to campaigning for making this claim and getting people to do something about it. For example, Population Matters, the outfit of which Roger is the chairman. Okay, so how might the arguments go? One would expect in general, at least prima facie, naively, that arguments for the population reduction claim would have to tangle with issues of population axiology. That's just because arguing for the population reduction claim is arguing that a lower population would be better than a larger population, and the theory of population axiology is the theory of how you make betterness comparisons between scenarios that differ over how many people there are. So prima facie you'd expect there to be some connections that need to be made when we're giving any arguments for this claim. Theron has already said a little bit about what sorts of things would count as a population axiology. We've seen the average view, the total view, and a bunch of other candidates. A key observation for the purpose of my talk is that, in general, the total utilitarian tends to be the guy who's in favour of larger populations compared to anybody else in this population axiology family. So dialectically that's important if you're arguing for population reduction, because one strategy is try to convince the total utilitarian. If you can convince even the total utilitarian that a lower population would be a good thing, then you can convince everybody. And so then your arguments will be on a stronger footing. They won't be making controversial assumptions in population axiology. There won't be arguments that only appeal to people who have particular idiosyncratic population axiological views. So I want to think about whether considerations of climate change give us this kind of reason, an even total utilitarian convincing reason for reducing population. Here, in general terms, is a preliminary attempt at a partial taxonomy of ways you might argue for population reduction. What I'll call type 1 arguments focus on some particular type of physical resource, say food or water or renewable energy supplies. And they focus on resources which have the feature that, at least arguably, in some sense, the planet supplies us with a fixed amount of this resource per year. In particular, the amount we get is independent of population size. If you've got a resource like that, for example, solar radiation, then you can argue along the following lines. Okay, the planet gives us this much of this resource per year. That amount of the resource has to be divided up somehow between the people who are on the planet. So if we've got fewer people around, we can have a larger share each. And so, other things being equal, you'd expect a higher standard of well-being on average for each individual person. You might try then to conclude from that that the lower the instantaneous population, the better, at least with respect to this resource. You see a lot of arguments like this in the population reduction literature. For my purposes, the key feature is that those arguments, at least as I stated them, only work if you presuppose average utilitarianism. They only establish that, if anything, that individual well-being is higher when you've got a lower population. And if you're a total utilitarian, that's not enough to get you to conclude that a lower population is better. So for my purposes today, I'll set aside those kind of arguments. I'll also set aside arguments that are, in some sense, are at the other extreme, what I'll call exogenous cap arguments. I think Roger's going to talk about arguments of this form tomorrow. So here the idea is, we've got some notion of carrying capacity. There's just some upper limit on how many people the planet can sustain. So the discussion we should be having isn't really about whether to reduce population or not. One way or another it's going to reduce anyway if we get close to hitting this cap. It's just a discussion about how to reduce the population. Do you want to reduce it the nice way by deliberately reducing the birth rate, or do you want to let the planet reduce it for you the nasty way by bringing about lots of deaths from famine, conflict, etc.? That's a very robust argument if you can get it to work. Any remotely sane population axiology is going to agree that nice ways of reducing population are better than nasty ways. So that's another way you can convince everybody if you can convince anyone. But again, I want to set those arguments aside for the purpose of this talk. So my focus is on the type of argument in the middle, what I'm calling long-run arguments for reducing population size. The basic idea with the long-run arguments is that it might be in a certain sense short-sighted to have too high an instantaneous population in the short to medium term, in the sense that if you have too many people on the planet in the next 100 years, the result of that might be that the planet gets stuffed up in some specifiable sense, climate change perhaps, with the further consequence that once the planet's been thus stuffed up, it will be less able to sustain human life in the future, less able to sustain a large number of people, less able to sustain a high quality of life. And if you think that, then even the total utilitarian might think, okay, it's a bad idea to have too many people around in the short term, because ultimately what we care about is the total sum of well-being across all time, and we might be paying too high a price in terms of total well-being, counting from 2100 onwards, by having too many people around in the short term. So here's a little picture just to illustrate that. So in these diagrams, I'm drawing population size coming out of the screen, time on the left-to-right axis, average quality of life on the vertical axis. If you think the trade-off in, say, a climate change scenario is between scenario 1, where you have a high population, 4 bars of population now, but then you stuff up the planet, so in the future you can only have a small population and you can only have a low quality of life, on the one hand, or scenario 2, where we exercise a little bit of restraint, we have a slightly smaller population now. As a result of that, we don't stuff up the planet, so we can continue to have the same size population with something like the same quality of life in the future. You can see from just the graphics of these graphs that the thing the total utilitarian wants to maximise here is the whole volume of the graph into the future, not just now. So she might very well prefer scenario 2, exercise a bit of restraint on short-term population, to scenario 1. Okay, so now my question is that going to happen in the case of climate change with the facts as they are? Okay, so here's the bit of rhetoric that I'm going to attack, but with thanks to its author for at least saying things explicitly so that I've got something to shoot at. This is Jonathan Porritt, writing in an article in the New Internationalist a couple of years ago. Arguing for population reduction, he says, look, at one level this is all about basic mathematics. We roughly know the total volume of greenhouse gases we can put into the atmosphere over the next few decades if we're to stay the right side of the 2-degree increase by the end of the century, which scientists tell us we absolutely mustn't go above. That total volume has to be divided up between the total number of people doing the emitting. And then Porritt continues, I believe it's part of our duty to the next generation to advance the compassionate progressive case for a full-on global campaign to put the world on a downward population trajectory just as fast as we can. Okay. So on reflection, I think it's not entirely clear which form of argument Porritt intends here. I think this passage could equally be interpreted in 2 ways, corresponding to what I was calling a type 1 or a type 2 argument for population reduction. Both arguments start with a claim that, in order to avert dangerous climate change, we need to stay within some given total emission rate. The first kind of argument would then continue, okay, so this is like having a resource flow of a fixed type. Here comes the type 1 argument. As a planet, we're allowed to have total emissions are whatever that number is per year. Now divide that ration up between the number of people who are on the planet in any given year. That gives you your individual allowance of carbon emissions. That's how much you're emitting you're allowed to do as an individual without risking dangerous climate change. And that individual ration is going to be higher the lower the population is. So if you think your individual well-being goes up as you get allowed to do more emitting, then this will be an argument that the lower the instantaneous population, the better. For the purposes of this talk, I'm uninterested in that argument for the reason that I'm uninterested in type 1 arguments generally. It's an average utilitarian argument, and I want to be more ambitious. Okay, but the Porritt passage could equally be interpreted as a type 2 or long-run argument for climate change. You might be saying something different, like the following. Same starting point, claim that in order to avert dangerous climate change, we need to stay within some given total emissions rate R. But then the key idea with the long-run argument would be, okay, that's what needs to happen if we're going to avert dangerous climate change, but it's not a foregone conclusion that we're going to succeed in doing that. It's rather difficult actually to reduce total emissions rate. If we go for a lower population, that increases our chances of keeping the total emissions rate within this cap R, and so it increases our chances of averting dangerous climate change. Therefore, the lower the instantaneous population, the better. That, I think, is a better argument than the first one because it's not totally utilitarian in character. But actually, both of the arguments are fundamentally flawed, on my understanding, because the very first step, the step that's common to both the arguments, is based on a misunderstanding of basic climate science. And now I go on to the slide that Brian skipped over, the penultimate slide in his talk. So the key thing that's wrong with Porritt's arguments, at least as I've understood them, is the following. Current climate science tells us that if the thing that you care about is peak number of degrees of warming, so whether the maximum number of degrees of warming we eventually end up with is 2 degrees or 4 degrees or what, if that's the thing you care about, all you actually need to know is cumulative emissions of carbon, or carbon equivalents, methane, etc. I'm putting those aside for this talk. You don't need to know the timing of those emissions. You need to know how much carbon gets emitted in total from the beginning of the Industrial Revolution up to the point where we manage to get carbon emissions to zero, if indeed we ever manage to do that. So these are emission scenario graphs like the ones that Brian was showing in his talk. In the left-hand slide here, you've got one benchmark scenario in red, and you've got a bunch of other curves which share with the red feature the fact that the area under the curve is 1 trillion tonnes of carbon. So they have the same cumulative emissions. They differ over the timing. So some of the orange curves do more emitting sooner and less emitting later. For some of them it's the other way around, but they hold fixed cumulative emissions. You then run your climate models on these various possible emission scenarios to generate your predictions for what the temperature response of the climate system will be. And what the climate models tell you is that if all you care about is peak warming, you get exactly the same predictions for all these red and orange lines. So these are the temperature predictions. All the red and orange lines are plotted in this diagram. You can only see one line because the lines are all exactly on top of one another. Okay, so putting that together with the Porritt line of thought then, would it be a better thing? Would it be an improvement if we reduced population size? You might think, well, actually it's not very clear anymore, or it's not so clear how the logic is supposed to go. Suppose we reduced instantaneous population size. Let's take an extreme case. This is of course not going to happen. But to take an extreme case to make the arguments clear, suppose that tonight half the people on the planet die. So we get a sudden reduction in population by a factor of a half. What would then happen? Well, the details are arguable, but let's consider various things that might happen. I've superimposed a green line on this graph. This corresponds to half the people dying overnight. So total emissions go down by half when half the people go away. Suppose that what then happens in the future is the following. Compared to the business as usual scenario, which is this black one, we hold fixed the amount of emitting that the first person born tomorrow does, the amount of, over the whole course of their life, the amount of emitting that the second person does, the amount of emitting that the 30 billionth person born starting tomorrow does, and so on. If that's the result of our instantaneous population reduction, then what we've done to our emissions is spread them out over a longer period of time. But what we crucially haven't done is made any difference at all to cumulative emissions. So, if that is what happens when you reduce population size, the impact of reducing population size would be to slow down climate change, but it wouldn't, according to the latest climate science, make any difference to the number of degrees warming you eventually get. So now you might start wondering, well, if that were the scenario we're talking about, is it actually any improvement over the status quo or not? Okay, so I've got two questions. These are the two questions that I think a population reduction campaigner might want to focus on to take the discussion forward from here. Firstly, can we, as population reduction campaigners, if you want to put it sort of adversarially, can we argue that even if we were just talking about merely slowing down climate change, can we argue that that would be an improvement over the status quo? Secondly, so alternatively and or additionally, can we argue that if you had a reduction in instantaneous population size, this red line here wouldn't be the result. The result would be something more like the blue line, so we would actually have reduced cumulative emissions, and hence we would actually have reduced not only the pace of climate change, but also how much climate change ever occurs. If the answer to either of those questions is positive, then we might have an argument in favour of population reduction from climate change. Okay, so what I want to do in the remainder of the talk is just make some initial, rather cursory stabs at what good versus bad attempts at positive answers to each of these questions might look like. So taking the first one first, would just slowing down climate change, if it didn't change, say, the fact, if it is a fact that we end up with 4 degrees warming eventually, would that be an advantage? Here's what I think are some bad reasons for saying it might be an advantage. I think they're bad because they rest on assumptions in ethical theory that I think are mistaken, and I'm not alone in that, but I'm not going to argue for them here. So the first idea is based on the thought that, okay, look, suppose we reduce population, so we slow down climate change, we don't change cumulative emissions, but we've at least made it the case that the climate change, the 4 degrees warming or whatever, hits us in, say, 2250 rather than 2150. We've managed to delay things by a bit. Then you might think, well, you know, that's at least some improvement because now we've got more time for the human race to enjoy the relatively benign climate that we've got before the climate change. And the disaster's still going to occur eventually, but because it's later, there's more time for humanity to enjoy the good state than there was under the business as usual scenario. Okay, that kind of reasoning would be regarded as valid by some population axiologies. But on reflection, it's rather bizarre because the sense in which there's more time for humanity to enjoy the benign climate in this kind of scenario is not a sense that involves more people getting to live out their lives before the climate change hits, right? If it was 30 billion people having the good climate before, it's still 30 billion people having the good climate now. You've just stretched out those 30 billion people over double the length of time. And that doesn't look like any kind of moral improvement. So I think that's a bad reason for favouring population reduction. Correspondingly, I think the population axiologies that validated are mistaken population axiologies. There's another reason you might have for thinking that a mere slowing down of climate change would be a good thing. You'll think this if you believe in what economists call a positive discount rate for future well-being. So here the idea is something like, sure, we care about all future suffering, but we care more about the near future than we do about the far future, just because it's the far future. So if climate change is going to cause some suffering, if we slow it down so that the suffering happens in the further future, then we should now care less about it because it's further away. Okay, so I don't like that line of argument because I don't think there should be a positive discount rate on future well-being, but as I said, I won't argue that here. Here's what I think is a better place to look for an argument that even just slowing down climate change would be a good thing. This is about adaptation. So here the idea is, okay, look, the physical science makes predictions for us about what the physical effects of climate change will be. And we care about those things, but they're not the things we ultimately care about. What we ultimately care about is the impact of those physical changes on the lives of human beings and, yes, other sentient creatures. But the amount of impact that a given degree of climate change has on human beings depends not only on how many degrees of warming there are, it also depends on how much adaptation has taken place. So, for example, if you're talking about extreme weather events, heat waves, cold snaps, if you think that one of the significant contributors to climate change damages is increased mortality due to increased frequency and severity of these extreme weather events, well, how many deaths there are in a given heat wave depends not only on how hot the heat wave is and how long it lasts, it also depends on how much air conditioning people have got. Similarly for cold snaps and quality of thermal insulation in buildings. So if you think that by slowing down climate change, you make it the case that more adaptation can have taken place before the climate change hits, then you might have reduced damages from climate change, even though you haven't changed the amount of climate change that eventually happens. I think that line of argument is worth looking into. I don't think it's entirely obvious that this would be the case, however. And the reason relates to some of the things that Toby mentioned in his talk. The point is that in many of these cases, it's human beings who are doing the adapting. So this is particularly a concern for adaptations that rely on technological breakthroughs, right? So if you think that, say, building I don't know, building sea defences of the required quality is something we're not yet able to do. This is probably a bad example, but you can think of some better ones. If you think that building sea defences of the required quality is something that would require technology that we don't currently have, then the process of adaptation is relying on there being certain advances in technology. And as Toby was discussing in his talk, it's not plausible to think that the rate of technological improvement will be held fixed if you vary the population size. If you have a lower population, you have fewer people working in research and development, so you've probably you will have slowed down adaptation as well as slowing down climate change. The issue is now a quantitative one. It's about the race between those two things, and it's less clear how the details are going to play out. Okay, so let me move on now to the other question. So my question 2 was, might the population reduction campaigner argue that a reduction in population is a good thing from the point of view of climate change? Because actually we're not talking about a mere slowdown. This red line is not what would happen to our emissions profile if we had a reduction in instantaneous population. It's more like this blue thing where you have a reduction in cumulative emissions. Can we make an argument for that being the case? So again, I think there are promising and unpromising ways of arguing for a positive answer to that second question. The less promising one goes something like...
20 minutes.
Okay, thanks. The less promising one goes something like this. Okay, in all of the emission scenarios we're talking about here, as Brian mentioned very briefly, we're talking about eventually getting to zero emissions. In particular, we're talking about within the next 100 years or so getting to basically zero emissions. It looks as though that is going to require, among other things, significant advances in technology. Maybe the only way you can get anywhere near zero emissions while having anything like our current quality of life is to have, say, a much cheaper way of manufacturing solar panels so there can be an awful lot more of them around. Or you've developed your carbon capture and storage technology so that we can do it an awful lot more cheaply than we can at the moment. You can make it economically viable to do it on a much larger scale. Well, again, if those sorts of things require technological breakthroughs, then if you're thinking, okay, the date at which every given technological breakthrough is going to occur is independent of how many people are around. So if the technological breakthrough that facilitates cheap solar panels, say, is going to happen in the year 2050, regardless of population size, then you'd think you're going to decrease cumulative emissions if you reduce instantaneous population size, because fewer people will have been around doing their emitting before that technological breakthrough occurs and facilitates lower per capita emissions. I think this is an unpromising line of argument, however, for the same reason, that it's not plausible to hold fixed the date in which technological breakthroughs occur if you're talking about massive reductions in population size. It's people working in R&D who are going to generate these technological breakthroughs. Fewer of them, later technological breakthroughs. I think there is, however, a much more plausible way of arguing for the same conclusion, and this goes back to one of the first things I said in my talk about renewable energy. So if you focus on, for example, solar radiation, you've got this thought that, at least to a first approximation, the planet is supplying us with a fixed amount of each renewable energy resource per calendar year. If you have fewer people around, then again, each individual person gets a greater ration of each renewable energy resource. If there are 3 billion people rather than 7 billion people, then if I'm an average person, I get to use more solar energy, I get to use more wind power, I get to use more wave energy. That means that holding fixed the individual per capita energy consumption of each individual, you can have lower per capita carbon emissions because, okay, I want to do this much energy consumption, I've got a higher budget of personal and renewable resources, so I can, whereas I previously only had this much ration of renewable energy resources, now I'm allowed to use up to this much, and so I've got a much smaller shortfall that I need to make up from fossil fuel consumption than I would have had in the higher population scenario. So I think this kind of thing is a reason for thinking that if you reduce instantaneous population, you are talking about lower cumulative emissions, not just a lower emissions rate, and that for that reason, reductions in instantaneous population size do look likely to lead to a lower degree of eventual climate change. Of course, if it's the total utilitarian we're trying to convince here, that just shows that there is some benefit to reducing population size, and if you're a total utilitarian, then there's also an obvious cost to reducing population size, namely all the lives that don't exist that you think would have been valuable. And we have to do the weighing up against these, we have to weigh up those two things against one another. But at least we here see how the positive side of the argument might work. Okay, so in summary then, if one's arguing for the claim that a lower instantaneous population would be better, in general there's a danger that one's arguments require controversial assumptions in population axiology. And as Theron mentioned earlier, that's bad news for your argument if it does have that form, because there's nothing approaching a consensus in population axiology. If you want to convince everybody, then you want to free your arguments from that dependence if at all possible. From this point of view, so-called long-run arguments form quite promising strategies for, if you like, the population reduction campaigner, because they're aimed at convincing the total utilitarian, and if you can do that, you can probably convince everybody. It looks as though it might be possible to do this from considerations of climate change. Where I've got to in my current thinking about this is, yeah, it looks as though this might be possible, but the details are pretty intricate. We got into some sort of complex-looking trade-offs involving relatively sophisticated pieces of economic theory in the kind of ideas I was exploring in this talk. It's at any rate not just the matter of basic arithmetic that Porritt was suggesting in his New Internationalist article. According to my extremely cursory survey just now, the most promising versions of this argument are firstly ones that focus on the fact that you've got a fixed supply of renewable energy per calendar year. And so you might be talking about lower cumulative emissions if you spread people out more in time. Secondly, you might argue that even if you're just talking about slowing down climate change, that might be a matter of lower climate change damages, because it would help with the process of adaptation. The end.